Oh.
The whole point of these identities are
that one.
To build up some math skills perhaps, but you're really going to end up using these in calculus. Not a ton, but they do crop up pretty often.
Did you say crap up?
Crop. They crop up.
Crop, okay.
They come up.
All right.
Every now and then.
All right.
And so basically it works out to where if you can sometimes change what you have with sine and cosine to some powers, it makes the calculus-y thing that you do easier.
Sometimes that is true.
So in this case, this would be where we were taking like some fancy word that you haven't heard yet of this on the left side, but if we could change it to what's on the right side, it'd be easier. So that's where this is like a legit, you'd use this in calculus kind of a situation.
And as a calculus teacher person, I would say that this is totally an applicable thing that we're working on here. Because there are times when you need to rewrite stuff.
Like this.
For ease of calculusing.
Yes. Notice that we have one cosine over here, and all the rest of this stuff is sines. That helps us kind of figure out where to go, because if you see we've got cosine to the 5th power, well,
that's an odd number.
That's an odd number. So what we can do actually, and because of the Pythagorean identities, we can split that cosine to the 5th up into cosine squared, cosine squared.
See, that's good.
It leaves us with that cosine.
I was thinking cosine to the 4th would have been and then cosine.
But I like splitting it up like that because now
that's genius.
We don't want to change the sine squared because there's sine squareds here.
Yeah.
But cosine squared, looking at your Pythagorean identities,
it's 1 minus sine squared.
1 minus sine squared. 1 minus sine squared. And cosine squared again is 1 minus sine squared.
Now, here's where you get to practice foiling out this puppy. And again, you need to recognize some tips and tricks to foiling out things that are identical, because it really makes life easier in the long run.
Right. There's a pattern that you do 1 squared, which is 1. There's going to be twice as much of these two terms, like
2 times 1
2
times sine squared x.
Yeah, so -2 sine squared x. And then
square the last term plus sine to the 4th x times cos x. I already like how this is looking.
Distribute the sine squared, and then we've got what we need. So sine squared.
So it wasn't as bad as it originally looked.
No, not at all.
Mrs. Stevenson, it's actually pretty legitimately doable.
And I don't know, like the book keeps putting these like random cosines in parentheses. You don't really necessarily.
Yeah, you don't need it. You don't need it.
Could have just been a cosine on the outside.
Yes, that is correct.
So that's it. That's 5.2.
There you go.